Okay, cool cats and kittens. The last thing that we talk about in our States of Matter chapter in honors is a little introduction into water. We're going to do a whole chapter about different kinds of solutions, and we've been talking about water as we've been going on, but it's really important to know some very crucial different things about H2O. And one of those is its density as solid ice. Okay, water at room temperature is going to have a density of 1.0 grams per milliliter. So what that means is that if ice in the solid form is 0.92, ice floats in water. And you're like, duh, I know all about that, Levin. I've had ice and ice water, and all the ice cubes are up at the top, and the water is down at the bottom. But what you might not realize is why that happens and why I'm going over it right now. Because believe it or not, it's a big deal. Okay, so water, when it is flowing in the liquid form, is very loosey-goosey. And you have your hydrogens and you have your oxygens, and they can be really, really close together, kind of tightly packed like so. Okay, so they have that density of 1 gram per milliliter. All right, and they're moving and they're shaking and they're flowing and bopping into one another and whoosh, 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 whoosh all around. But in the solid form, they have to quote Beyonce, get in formation. What that means is that the oxygens have to be in a very specific place and the hydrogens need to be in a specific place so that the next hydrogen and the next oxygen and the next hydrogen and the next oxygen and so forth are all going to match up because they are going to be locked in their position. And when they're locked in their position, they have to be this plus, minus, plus to minus to plus to plus, all those partial positives and partial negatives in there. So when that happens, these loosey-goosey things right here have to spread out, which is why we get more room, more volume. So then density is going to decrease. All right. So you're like, okay, I never thought of it that in depth before. Geez, well, Jen, you got to make me do all that. Well, it's kind of important because this water in the liquid form and solid ice form have these two very different densities. It is one of the only exceptions to the rule out of 4 million plus known substances that occurs naturally in nature to be more dense in the liquid form than the solid form. Okay? There are others, gallium, bismuth, germanium, and silicon, but you don't really find them in element form. You find them in compound form. Okay? So this is really the only naturally occurring substance to do this. So you're like, what is the big deal? Well, when it steps into formation, it makes those tetrahedral holes, which is basically like this empty space that is going to make all of this expand. And when that happens, okay, what happens to nature? Think about what happens in the wintertime. What does a lake, a pond, an ocean, a stream, a river, a whatever do? Does it ice under or does it ice over? You're like, well, duh, it ices over. So what is the big deal? Why are you making a whole separate video about this? The reason is this is a complete freak of nature thing. And the reason why this is such a big deal is because everything else does something opposite. So if it were not for this incredible exception, okay, life would not evolve and exist. You heard me. Think about it. If in a pond you had ice, okay, on top, like you have now, everything can live underneath it. Okay, this little fluffy kitten can try to go and get the koi fish, and the koi fish are okay. And I don't know if you've seen any YouTube videos of this, it's like really crazy. But under the ice, life can still exist. If not, what would happen? If it actually iced under, so if here is your pond, let's say, and here is your ice, what would little fishy eat? Would it be able to eat all the things that are hiding in here? No. And what would happen to the fish? The fish would die. And what would happen to the things that eat the fish? They would die as well. And so on and so forth in the great big circle of life. All right. So, yes, this snapping turtle can still exist under the ice. And yes, these seals can still eat under the ice, and life can exist in the Arctic. Um, and I don't know if you saw this of the alligators down in Florida, but it got real, real cold, and their body temperatures dropped so much, and it just had just its nose out. That's all the energy it had. Its heart was beating, I think, maybe once per minute until all the ice ended up melting out of northern Florida with a really cold spell a couple of years ago. But I mean, it's just absolutely crazy that this one exception to the rule makes for such a big deal. Because who knows if we would have evolved the way that we would have evolved, and if life would have evolved the way that it did, if it were not for icing over as opposed to icing under. Because all other substances would form their solids on the bottom as opposed to their solid on the top. And then, do you know what the real tragedy is? We would never have ice hockey. And isn't that a tragedy? Because go Flyers. Gotta love my gritty. Gritty, gritty, gritty. All right, everybody. That is States of Matter. Hopefully, I gave you guys some things to talk about and think about. All right, till next chapter. Be well.